So this is our grid connected inverter. Here's our inverter, our low pass filter, breaker, and then the grid. So we're gonna go through each of these. We have a VDC of 212, that's our input voltage. Okay, going into our PWM block, we have a modulation index of 0.8, 900 for our carrier frequency, 60 for our output voltage frequency. Now, checking to see how our inverter is operating, when I run this, we can expect square waves for each of these phases. As you can see, phase A, phase B, phase C. Now, we're going to connect our inverter with the low pass filter, and we can expect clean sine waves if our filter is working properly for each of these phases. Just to show you our inductor value, 2.2 microhenries, and our capacitor value of 1.1 farad. Now, when I run this again and scope our inverter after our filter, we can see clean sine waves for phase A, phase B, and phase C. Now, we're going to move on to the grid, but between the grid we have a breaker located right here where the mouse is. Now, to show you our phase A with our grid, you can see that this is our phase A voltage and frequency, and our grid voltage and frequency. The frequency of both is 60 hertz at a peak-to-peak value of 240 volts. Now, when we check all three of these phases here, we can see phase A, phase B, phase C of our inverter, phase A, phase B, phase C of our grid. And you can see that they are both matched and synchronized, both in voltage, phase, and frequency. That is our inverter connected to the grid.